Hi guys, welcome to the explanation for PT 1111. Looking at this as part of our games course. This is a game where distribution is not too flexible. So you can do a lot of quick thinking based on that distribution about, okay, this group is full. What do I have to do now to fill up the other groups? That kind of thinking is always so key in these games. Okay, so in this game, we're looking at putting these camp counselors into these activities. So here are 8 counselors up here, and these are the 3 activities they're supervising. We got swimming, tennis, and volleyball. So let's take a look at distribution, because that's always the first thing we want to be thinking about in these games. They tell us here that each activity is supervised by at least 2, but not more than 3 of the 8 counselors. So I'm going to want 2 solid lines like I've got here that shows me that these spots absolutely have to be filled. Now, as far as what the distribution here is going to look like, we got 8 into these spots, right? So since there's 3 max, the most you're going to get is, this one full, and one of the 3 is going to have to not be full. So we could have, 3, we could have 3 here, and then here there's only going to be able to be 2. And you can float that around however you want. So the distribution here, if we're making a little chart for it, is simple 3, 3, 2. That's what it's going to look like to get these 8 pieces in here. And of course, which groups have the 3 and which has the 2, that can move around. Next, we get a little more specific with the rules. Henry supervises swimming. Neither Kathy nor Olga does tennis, so we have some restrictions there. Now, neither Kathy nor Nathan does the same activity as Joan. So that's really 2 separate rules. Nathan can't be with Joan right here, and Kathy can't be with Joan. See them together, and you run into trouble. Next rule looks really intimidating, but just handle it like any other conditional. If George supervises swimming, then Nathan does volleyball, and Olga does volleyball. So OV. And contrapositive to that, just make sure to switch your operator, not NV or not OV, then you can't have GS. So this is really, really flexible. Scenarios are not going to play a role in this game at all. There's no way you could fill up, all the different ways that you can fit these pieces in and get it all drawn out. It's just not going to happen. But it's a game 1, so I'm not really worried about it. They're going to give us a lot of information and usually fairly easy questions since it's a game 1. So we'll just keep an eye on the 3 groups and which has to be the 2 group, and should be pretty easy to solve this really quickly. We're going to skip question 1, the acceptability question. You just handle that the same way you do any question, any acceptability question. Take your rules one at a time, see where they're violated. So let's move on to question 2 here. Which one of the following is a pair that could be 2 of the 3 supervising swimming? So it's a could be true, and it's an early question. So I'm thinking these rules, these choices here, these answer choices, you should be able to see just right away that there's something wrong with them, since it's only question 2. Remember, the first questions in games are usually pretty easy. So how about George and Nathan in swimming? Well, if George is in there in swimming, then that kicks Nathan into volleyball, right? So this is out right away. Sorry, let me switch to my blue pencil here. What about George and Olga? Same thing. George is in swimming, that kicks Olga into here. So B's gone. Joan and Kathy, that just violates this rule straight up, so that's easy. Same with Joan and Nathan, and we're left with E. Okay, for 3, we just need a pair who could together be assigned to supervise tennis. So again, there's nothing you can do but evaluate each of these one at a time. So how about Fran and Kathy in tennis? Fran, Kathy in tennis, that just violates this rule right here, straight up. So that's out. How about George and Nathan? When I look at that, I say, okay, well, I don't see anything immediately wrong with that. So here's a common strategy on these games. Rather than trying to build an order, which is going to take a long time, if you don't see anything immediately wrong with B, just leave it and see if you can see something immediately wrong with all the other ones. So how about Henry and Lewis in here? Well, H is already stuck in S, so that can't work. How about Joan and Nathan here? No, that's violating this rule, so that's out. How about Joan and Olga? Joan, Olga, it's just violating this rule right here. So again, this is all softball stuff, but you can save yourself some time by just going to elimination rather than trying to make a whole order for B that works. Okay, for 4, George and Kathy are 2 of 3 assigned to swimming. So we just pop George and Kathy in here. And then I want you to note right away, that kicks N and O over here, per this rule down here. So N and O go in here. And then I'm thinking, okay, well, J can't be with N, right? So that kicks J into here. At that point, I want to see if I've answered the question. So what could be true here? How about Fran in swimming? No, that group's already full, so simple distribution issue right there. How about Henry in tennis? No, he's always in swimming. How about Joan in volleyball? No, Joan has to be in T. That's that last inference that we made. What about Lewis in volleyball? Lewis in volleyball? Sure, why not? Just throw him in there. There's nothing wrong with that. If you want to look at it quickly and just go to elimination here, N and T for this last one, N stuck in V. We knew that right away. So that's out, and it leaves D as the right answer. Okay, for 5, we got Fran and Lewis assigned to swimming. And they're 2 of the 3. We know H is in there already, right? So what can we do here? Well, we didn't use K and O, so they're now both getting kicked into here because they can't be in the middle, right? And then when K's here, I'm looking now, what rule does apply to K? What rule applies to K? It's this right here. So J now has to get kicked into the middle. And I've done a bunch of work now, so I want to see if I can answer the question before I do anything else. What must be true? George and V. No, that must be false. How about Henry and V? Again, must be false. He's always in swimming. How about J and T? Yeah, J and T has to be true. We got that right here. So C is our right answer. Okay, for 6, if Joan's assigned to do the same activity as Olga. So we got basically a new rule here, just for this question. J is with Olga. And when you're thinking about what to do on situations like this, it looks like, okay, well, there's 2 places that can go. Can't go here because of this rule. So we could have J-O here. And if you want to do another order, we could have J-O in this group. So let's just redraw the diagram here. J-O, H would be here. These are our only 2 options. In both these options, you can't have G in S because, there's no room for it here. And if I have G and S here, that's going to send Nathan in here, and that can't be with J. So that kicks G out of S for both these scenarios. And when I see that, I just want to look at, it's looking for something that cannot be true of the assignment, and we see that right in the answer choices here. G cannot be in S. G not in S. Boom. B is our right answer on that last one. I think if you just build your 2 scenarios there, it's much simpler than just trying to, think about it more abstractly. Whenever I am out of things to do, I just start building scenarios. It's always the best way to get out of a jam. Okay, so that's the game. There we had a distribution that moves a lot more than we saw in the last example in the games course, but it still couldn't move too much. So we're still warming up a little bit. In the next examples, we'll move on to harder stuff.